Hello everyone, welcome to Anubhav Prakhya YouTube channel. Today I am going to discuss beta.inv function using Microsoft Excel 2016. You can see on my screen I have an Excel workbook open in which I am going to click on the formulas tab on the ribbon. I am going to click on insert function. Here I am going to type beta.inv. I'll click go. Now we are able to see the function here after we search for it, and I'm going to describe what this function is. This function returns the inverse of the cumulative beta probability distribution function. To get a complete understanding about the syntax of this function and a description and how to use this function using an example, I'm going to click on the help on this function link given here. This will open a new window or a new tab. Now we'll go through the function syntax and description, and we'll also be a little more hands-on in using the beta.in function by doing an example. So this returns the inverse of the beta cumulative probability distribution function. If probability equal to beta.dist bracket open argument x so on argument true bracket close. So this is an explanation for how do we use this function, what is this function about. So if probability equal to beta dot distribution function, then beta dot inv, which is beta dot inverse of probability argument comma and some other arguments would be equal to x. So we are going to get the returns. So we are going to get the value computed after this function returns the inverse of the beta cumulative probability density function. So the beta distribution function can be used in project planning to model probable completion times given an expected completion time and variability. Let's go through the syntax of this function. Beta.inv in, let's not use the complete word inverse because the syntax is beta.inv, bracket open probability comma alpha comma beta comma a comma b bracket close. The beta.in function syntax has the following arguments. Probability argument, which is a required input for the function to compute properly. This is a probability associated with the beta distribution. Argument alpha, which is another required input for this function to compute and give an accurate result, is a parameter of the distribution. Argument beta, which is also a required input, is also a parameter of the distribution. There are two more arguments which are not required, as in they are not compulsory, but these are optional. So if we choose to input these values, the function will calculate. If we do not input any values for the arguments a and b, which denote the lower bound to interval x and upper bound to interval x, still the function will be able to compute and give a result. Let's now go through some remarks to understand what do we do if we encounter any type of error value while computing or using this beta.inv function. If any argument is non-numeric, beta.inv returns the hashtag value error value. So if we encounter a hashtag value error value, then we have to make sure that the arguments that we used within the beta.inv function are only numeric. If alpha is less than or equal to 0 or beta is less than or equal to 0, beta.inv returns the hashtag num error value. So alpha and beta arguments have to be greater than 0 so that beta.inv function does not return hashtag num error value. Also, if probability is less than or equal to 0 or probability greater than 1, beta.inv returns the hashtag num error value. So we have to make sure that the probability argument values that we input should be between 0 and 1. Then we will not encounter this error, hashtag num error value. If you omit values for a and b, because arguments a and b are optional, beta.inv uses the standard cumulative beta distribution and uses the values for the arguments a equal to 0 and argument b equal to 1. So this is how the function will compute, and these are the types of errors that we may encounter when using this function. Given a value for probability, beta.inv seeks that value x such that beta.dist bracket open x comma alpha comma beta comma true comma a comma b bracket close equal to probability. Thus precision of beta dot inv depends on precision of beta dot dist. Alright, now let's go through an example using the Excel workbook which we have opened before. So we can either copy the data that we see here and compute using this formula, or we can type. So we're going to do both now. I'm going to copy the entries here in this table which are about data and distribution. So I have selected by clicking the left click and dragging the mouse cursor. Now I'm going to right click, or I'm going to type Control plus C. So I have to copy this entry. So I'm going to select these entries again, hold Control plus C. I have copied these values. Now I'm going to click on the Excel workbook, cancel the insert function, click on cell A1 and type Control V. So I'm going to paste these values. Now Excel is going to take some time to paste the example data and the description. Once we do this, we'll be able to compute by inputting the arguments for the beta.inv function. So because we are copying these entries, we are not going to type the arguments. We are going to reference to the cells in which these values are entered, which is what we have pasted down. So I'm going to show that to you and explain a little further. Now I have to click on this paste options and click match destination formatting to make sure that the formatting that we have copied is matching with the Excel workbook. So we are going to format the table and the example according to the way we use it, our convenience. Alright, so now you can see that Excel has pasted these values. Now I'm going to click on cell A1 and hold shift and click on cell B1. To bold the headings, I have to select both these columns A1 and B1. I'm going to click on home. I'm going to click bold. Now bold the headings. Now I'm going to click on cell A7. Also I'm going to click on the Excel help window and look for the arguments which are given here. So you can see that we have to create 3 more headings now: formula, description and result. First let's create these headings in the Excel workbook. So let's go back to the Excel workbook, click on the Excel workbook, select cells A7 to C7 and now click on bold, and now in cell A7 I have to click on the formula bar and type formula and type enter. Next I'm going to click on cell B7, click on the formula bar and type description. Next I'm going to click on cell C7, click on the formula bar and type result and type enter. Now I'm going to click on cell A8. Also I have to reference back to the Excel help to see how they have used the formula. So I'm going to click on the Excel help window and now let's go through this formula. So here it's given equal to beta.inv bracket open A2 comma A3 comma A4 comma A5 comma A6 and bracket close. So I'm going to left click on the Excel help window. Now in this formula I'm going to click on the formula bar and type equal to beta.inv. You can see that Excel has already shown this function here. Now I'm going to hold the shift key and open the bracket, and here I'm going to reference to the cells A2 comma A3 comma A4 comma A5 comma A6, close the bracket and type enter. Now we are able to see the result. We got a result after the computation for this formula. We got the result too. Let's verify this result with the Excel help window. So I'm going to click on the Excel help window. Here you can see that the result is given 2. Hence we can conclude that we have been able to compute accurately using the formula in this example. So now I'm going to click back on the Excel help window, click on cell A8, type Ctrl plus C to copy the value or the result that we got in cell A8 and paste the result in cell C8. So I'm going to click on cell C8 and then I'm going to right click and paste values. So I've pasted only the result in cell C8. Now I'm going to click again on cell A8, click on the formula bar, add an apostrophe to make sure that we are able to see the function on the formula that we have used. So I'm going to type an apostrophe and type enter. Now I have to click on the description, cell B8, and also describe what this function was about. So I'll go back by clicking on the Excel help window. Here we'll see what is given. The description is inverse of the cumulative beta probability density function for the parameters above. So to type the description in the Excel workbook. So I'm going to click on the Excel workbook and type in the formula bar for cell B8 inverse of the cumulative. I'm going to click on the Excel help again, beta probability density function. I'm going to click on the Excel help window, beta probability density function, and I'm going to click on the help window again for the parameters above. I'm going to click on the Excel window for the parameters above and type enter. Now we have completed an example. So before we conclude the class, let's adjust the column width. So I'm going to click here and select all the rows and columns in this Excel workbook. I'm going to double click on the column to adjust the column widths, and then I'm going to click on cell A1 and save the workbook. So we have completed the beta.in function. We understood the syntax and description, and we got a little hands-on by computing this function with few arguments that we created from an example, and we got a result. If you like this video, please like this YouTube video on Anirudh Prakhya YouTube channel, share this video from Anirudh Prakhya YouTube channel, and subscribe to Anirudh Prakhya YouTube channel. Thanks for listening. Have a good day.